Hello everyone, this is Rishikesh, and today I'm going to with the lead code weekly contest problem. Actually, at the morning I was not able to wake up earlier, so that I missed the weekly contest, and due to that, I'm going to give as a virtual. But no matter how I am giving virtual or the real contest, the matter is how much questions I am able to solve during the contest. That is what I am looking for. So let me give 1 second. Now, okay. Uh, just another second. Just another second. Okay. Now let's start, and I'm going to explain each and every question that and along with the approach, and I'll try to code along with you guys. So actually, this is the 1.5 hour long live streaming in which I'm going to explain the Leetcode weekly contest. I'm going to give. I don't even see the any of the problems of the contest. It is newly for me as well. So let's see how can I solve this question. How I am approaching the problems. Okay, go ahead. Let's click on to the join. Let me close the other tabs so that it will not going to create any issue with this. Okay, so first question will be easy, I think. Oh, it's already has been started. Not an issue. Not an issue. Will solve. Will solve. I don't know what is there any network issue or no? That's simply a network issue. Let me check again. What should I put? Yeah, that's working. That's working fine. That is working fine. Let me check. Go ahead and solve the. Yeah, sure. Let's firstly I'm going to read the problem, and then I'll share my approach with you guys. So you are given two integers array start and target. We have two arrays start and target, where each array is of the form x comma y. Okay, we only two integers. Projecting a cell on the at cross at chessboard right. Return true if knight can move from start to target in an even number of moves. Okay. Okay. And otherwise return false. A valid knight move consists of moving two squares in one direction and one square in perpendicular to it. To figure below illustration all the possible moves from a 7. Okay. 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 So actually let's understand the problem, and it in the problem it is clearly mentioned that we have to reach the target from the start node to the target node in the even number of moves. Like we can't need to reach in two moves. We can't reach in. We are not going to consider that answer in which we are going to reach with the odd number of nodes, but here we need to reach in even number of nodes. And firstly let me do one thing. Let me take this as a reference and explain this problem. 1 1 and 2 2 is the valid answer here, clearly mentioned that. So let's understand how we can solve this problem. Actually, firstly, I'm going to write all the. This is 1 1. Okay, 1 1, 1 2, 1 3. Okay, kind of 2 1, 2 2, 2 3. Okay, Okay, got it. So if I am on the 1 1, right, then where I can go? I can go to this node. I can go to this node. So from 1 1 to I can go to 2 3. Okay. From 1 1 I can go to 2 3. From 1 1 I can go to what is it? To 2 3 2 3 1 3 2. Okay. Okay. So 1 1 I can go to 3 2. Okay. And again, if you can see, then from 3 from 2 3 I can go to where I can go. I can go to 2 from 2 3. I can go to from 2 3. I can go to I can go to this node. Right. So actually, from 2 3 I can go to this node. I can go to this node. Hmm. I can go to this node, and if I can see here clearly, from this I can go to this 2 3. From 1 1 I can go to 3 2 as well. So if I am on the 2 and 3, uh, then I can decrease it by 1, so it will become 2. Yeah, this can also reach. So what was the I can go to here. I can go to here. From here I can go to here. Okay, and from here I can go to here. So it is 1 2 1 2 3 4. Okay, got it. So basically, we have seen that for like odd number of moves, we have to increase or decrease even one index even one index increase the one by one, and the second index should be increased by two. Okay, so or first can be increased by two, or second can be increased by one. Means that we have to maintain a difference of odd. Okay, one will be odd, one will be even. Okay, and here we have a minus one comma two. So here also, if you can see here, from 1 1 it is decreased by 1, this is increased by 1. So this is the even odd. So difference should be same. Okay, 2 1 should be 1. I can't comment about decrease. So actually, we have paid a 2. Okay, from 3 to we can go to 1 3. Okay, so in one move we can go to here, and in other move we can reach to 1 3. So here it is decreased by 0, it is decreased by, so decrease by 0 comma 2, 2 comma 0. Okay, so here in one move we got here, and second move we got here. So it should also divide it, right? Minus 1 0. So it should be increased by 1. Mm. From here, not getting the correct answer as of now, but what you can see is that uh, 2,3. Three comma two and three. 3 minus 1 is equal to 2. Difference is 1. Actually, not even able to understand what. Okay. Even Okay. And, I choose जीरा ओके जीरा बनाना चाहिए हम लोगों ने खाया Oh my God. Some dominant nodes in a binary tree. Let's see, we have a binary tree question. I hope you guys are understand after seeing this question. So you are given the root of the complete binary tree. So basically, I'm going to tell about what is complete binary tree. So in the complete binary tree, uh, all the leaf nodes in the leaf nodes, all the levels are filled. Okay, you can see here. considering complete binary tree. Despite a binary tree process, so every single level is fully populated with nodes except potentially the lowest level, which must be populated from left to right. Yeah. So given the root of the complete binary tree, not a root x is a node x is called dominant if its value is equal to maximum value among all nodes in the subtree rooted at x. Return the number of dominant nodes in the tree. Okay. So basically, 5. 1, 2, 3. 1, 2, 3, 4, 5. Okay. Okay. That is oh, a huge simple question. I'm going to solve in just a minute. Basically, when count is equals to 0, or we can't also make count. So public int function and tree node root. Okay. So all the roots values are in the range of 1 and 10 raised to power 9. Okay. And the number of nodes in the tree is range 10 raised to power, not an issue. We are only visiting all nodes at only one time. Okay. So if our root equals to null, then return -1. Correct. Otherwise, otherwise int left is equal to function a root dot left. It will gonna return left while int right is equals to function root dot right. Okay. Firstly, I'm going to explain the my approach, and then we're gonna code. Actually, I didn't even explain the code, so let me explain firstly code. Then we'll go ahead and explain the logic as well. As of now, let's see in the accelerator how can we solve these questions. So basically, yeah. So basically, I am on here and I am on the root node. If when this node will be dominant, the maximum from here, okay, and the maximum from here, I'll fetch maximum from this node, and I'll going to fetch maximum from this node. And let's suppose here maximum is 2 and from here maximum is 3, and if this node value is greater than the left maximum and the right maximum, then we can consider that this node is dominant. This is the basic questions and we have to understand this. And how, and on the each level, like I am here, then I am going to call a function to go and find from left side which is the maximum element from their left subtree, and my function will go and call from left side, and that will go and find out the which one is the maximum value in this in their left subtree, and it will going to return one. And also I call the same function to go and find the maximum element from their right subtree. Okay, and then this will going to come up with 2, and then I'll compare the left most element and the right most element with the node. Okay, and if node is greater than this left and right, then I can say that this is the dominant node. And if it is not, then I will return. I'll not consider this node as a dominant, but I'll return this values, maximum values from left and right, whatever it is. Here it is 2, so I'll return 2. Okay. So this is my approach. Let's code it. It's quite simple at all. If into max is equal to, okay, math, okay, math dot to max, okay, left comma right, okay. So What is strictly greater maximum among all the nodes equal to the maximum value if its value is equal to the maximum value among all the nodes in the subtree. Yeah, one, two, three, four. So the node with value 2 is subtree is 2, 1, 2 is dominant because its value is maximum value in its subtree. Oh, good second. So you are given a complete binary tree. A node X is called dominant if its value is equal to the maximum value. A node X is called dominant if its value is equal to the maximum value among all nodes in the subtree rooted at. So here to the leaf node is to dominant the node with value because okay, it may be equal as well. Okay. So if maximum is lesser than or equals to root root dot pal, okay, then we can say that then we can increase our counter, okay, and then return root dot value, okay. Either way we no need to return only max, okay. I hope this works. I hope this works. Into max is equals to function. Okay. Function. And max is equal to function. And we are passing root and returning count. Okay. I hope this will work. If it is, oh, if it won't work, then not an issue. Not an issue. Not. So five, five, four, four. Okay. That's correct answer. And now moving to the third question, let's we are trying to solve the third one. Transform binary string using subsequent sort. Okay, so transform binary string using subsequent sort. Okay, you are given a binary string S. A binary strings. So basically, the definition of the binary string is that this only includes either zeros or ones. Okay, so you are given binary string S. You are also given an array of string str. Okay. So you are given a binary string S. You are also given an array of string strs where each strings I has the same length as S. Okay. Okay. Understand. Trying to fetch. So I have a. Okay. So I have the. You are given an array of string strs. Okay. You are given an array of strings str where each strings I has the same length as consist of characters of this question mark also included. Each question marks can be replaced by either 0 or either 1. Either you may perform the following operation any number of times including 0. Choose any subsequence, a subsequence of S. Okay. Okay, let's see what is subsequence. A subsequence is a string that can be derived from another string by letting some unknown character without sending the other. It means that we can pick up some of the elements. It should not be in a sequence in a contiguous manner. So that is called the subsequence. And sort sub in non-decreasing order. Choose any subsequence sub of S. Okay. Choose any subsequent sub of a sort sub in non-decreasing order. So basically we have to sort that in increasing order. Replace the chosen subsequence image with the sorted sub, keeping all other character unchanged. Return a Boolean array answer, where answer I is the true. If it is possible to replace all question marks in the strings with 0 or 1 and transform into resulting strings using the allowed operation above, otherwise return false. Hmm. And transform S into the resulting string using the allowed operation above. Hmm. So we have we have 101. So you are given a binary string S. You are also given an array of string strs. Here each string has the same length. So we have array of string. Okay. So we have array of strings strs. So where each string has the same length. Okay. Firstly, this is correct. Where each string has the same length as consist of characters 0 and 1. So basically, we have also given a strs array of strings where each array has the size of s. Each array string element has a size of same as in s, right? And then this string also includes some of the question marks. So we have to replace that question marks with the either 0 or 1. You may perform the following operation in a number of times. Okay. Okay. Choose any subsequence of S. Basically, we can choose any subsequence from S, right? Let's see. A sort sub in non-decreasing order. So non-decreasing means increasing order. Okay. Sort sub in increasing. Replace the second errors with the sorted sub. Replace the chosen subsequence in S. Whatever subsequence we have been chosen, we have to with the sorted sum, keeping all other characters. Replace the chosen subsequence in S. What it is saying? Hmm. Replace the chosen subsequence. Whatever subsequence we have been chosen. Okay. Okay. It means that with the sorted sub. Okay, understand. So basically, question is saying that we have a string s 1 0 1 1 0, and we have to choose a subsequence. Okay, this is the subsequence 1 1 0, and we have to sort them, so it is sorted, and replace this with sorted ones. Okay, replace this with sorted ones, sort of keeping all characters unchanged. Right, got it. Return a Boolean array answer where answer I is true. If it is possible to replace all question mark and strings with zeros or other and transform as to resulting string using the allowed approach. So let's check it. We have a string 101 and this is 1. So for 0, this is 1. Replacement, we can do our replacement of 0. Then we'll got 101 or 101. So just to here, here we have a 0 question mark 1 0 question mark 1. We'll replace with 1 remember. Select the subsequence at index of 0 so August 0 set to 1 0 set to 0 1 2. Okay, 0 set to 0 1 2. of s sort to get 0 to not present. Select the subsequent indices. And then